Okay, virtual classroom norms. Everybody's doing a really good job with that, and everybody's in really good communication also. And I thank you for that. As far as if you are having a problem, you either email me or as you come aboard to the classroom, you let me know what's going on, which I do appreciate that. That's something I attempt to be in at all times is in communication. Sometimes I dop with that, but in any event, thank you for everybody, from everybody. Okay. No real announcements today. The only thing that possibly could be flying across the radar screen at this point in time is next week. Later on in the week, we will probably be looking at our second unit exam. Nothing will actually change as far as the procedures from last time. Pretty much the review sheets that you get for this and that we go over to prepare you for the unit assessment. The unit assessment will be basically the same thing. There won't be any words changed. There won't be anything, maybe the order of the questions, that kind of a thing. But what you have in your hands and what you have accessible to as far as the review sheets, that is the holy grail. Okay. There won't be any underhandedness going on. There won't be any curveballs thrown where you'll have a series of questions and all of a sudden the questions on the exam will be completely different. That will not happen. You have my word. And yeah, I know for all you football fans out there, the Packers got spanked yesterday. Bad day. Bad day. Anyway.
That was good.
Moving on. Today we're going to talk about intensive properties, and tomorrow is going to be extensive. So we know that the properties of matter, they're different. And depending upon what we are actually looking at, and what we could see, remember using our senses when we are talking about properties. Okay, now this is going to take it a little bit deeper because it'll talk about amounts, if that has any effect. Lost my train of thought. In any event, we will be going through this as far as intensive and extensive properties. So it'd be key at this point in time to have that notebook next to you. And I think what I would do for the next couple of days is I would actually have two like columns: intensive properties, extensive properties. Now, extensive, not really going to have a whole lot in it today, but tomorrow it will. And then you'll have a comparison. You'll have a sheet of paper in front of you that you can actually compare intensive to extensive properties. Okay, purely a suggestion, folks. We're all adults here, and you do what you feel is the best to help you succeed inside this classroom. Okay, but today is intensive. Now, we know that physical properties of materials. Now, we say materials, that is just the matter. It's another name for matter. And systems, it's groups of matter or molecules, let's say. Okay, that could be considered a system. Now, they could be either classified as either intensive or extensive. Now, again, here's our two columns that we're going to be looking at. Now, in those two columns, we are going to be listing certain properties when the size or extent of the system changes or how the system actually changes. And you'll be able to, at the end of all this, actually compare. Any questions? We have that set up in our notes. Okay. Now, an intensive property is a part of the system that does not, okay, and I will repeat that, does not depend on the amount or size, quantity of that system. Okay, the amount of sugar, let's say. Whether you have a teaspoon of sugar or whether you have 5 pounds of sugar, Okay, it is still sugar. There's no change in that. Okay, any questions? So, an intensive property is a part of the system that does not depend on the size or amount. And I think for right now, what I'm going to do is that right there. It does not depend on the size or the amount. Here are some examples. Color, odor. It doesn't matter how much color you still have color. It doesn't matter how much something smells, odor. It's still the odor. How shiny something is. Okay, you could go right on through this. Density is another. Conductivity. What does that word mean? What does conductivity mean? And actually, I'm going to go to the left on all three of these. When we say something can conduct electricity, like the wires in our wall can conduct electricity, can anybody tell me what that word conduct means?
To collect, I'm pretty sure.
Think about throwing a light switch on. Think about throwing a light switch on. What happens?
It turns stuff on.
Absolutely. You hit the switch, and all of a sudden, the electric current can be conducted to the light or to whatever you're turning on. Absolutely. So, the ability to move electricity, so to speak. How about ductility? How are those wires made? When we say that something is ductile or has a is duct I don't know how to really want to put this. The ductility of something is the ability for a metal to be stretched or pulled into um, thin wires. So that's how the electricity goes from the switch to the light bulb. It's because those wires have been stretched. Now, how about malleability? We've talked about this before. If we know something is malleable, what does that mean? A jeweler. Nobody? When we say something is malleable, it has the ability to be pounded into thin sheets. Okay? So, but they are all examples of intensive properties. So there you would have a whole list of things in the intensive property column. Electrical conductivity, we talked about this. It only is a property that depends only on the type of substance. So we know that most metals have the ability to conduct electricity. It doesn't depend on the amount. It depends on what it is. So that copper wire doesn't depend on how much you have of it. It will all conduct electricity, whether it be that coil of wire, which we'll see a picture of it later, or a small piece of it. Any questions? No questions? Okay. Silver and gold and copper are excellent conductors of electricity. While we know that glass and plastic, they're very poor conductors. Very, very poor conductors. And believe it or not, in the old days, it's not very safe. But if you, in the old days, where there were screw-in fuses, rather than breakers in our electrical panel boxes. When something was wrong and somebody needed to have electricity, what they would do is they would take a penny and they would screw the fuse in against the penny in the panel. They didn't have another fuse. Okay? And that allowed the electricity to be conducted throughout the house or wherever that circuit was. Whether that made sense or not, it is just a point that the metals, the copper, the gold, the silver, all can conduct electricity. And it doesn't matter how much you have of either of the substances. The glass or the plastic, it doesn't matter whether you have a big piece or a little piece. You have, it really doesn't matter. They are all very, very poor conductors of electricity. Conversely, with metals, it doesn't matter. And we're going to come to that here pretty shortly. Doesn't matter in the amount. Okay? We went through all these again. So here's another opportunity for you to actually see different types of intensive properties: color, odor, luster, melting and boiling point. Specific heat, we'll get into this a little later in the course. We talked about malleability, the ability to be hammered into thin sheets; ductility, the ability to be stretched into thin wire; conductivity, the ability to move electricity or heat. Okay? Density and pressure are all good examples of intensive properties of matter. And I'm changing the font color, here while we're going along. Okay? Copper wire has a certain electrical conductivity. This wire, or these wires here, can only carry a certain amount of electricity. That's not the point. The point is that it doesn't matter whether you have this whole coil or whether you just have one little piece of the coil of wire. It will all conduct electricity. We all clear with that? Give me a
Yes.
thumbs up, a yes, a yay, nay, something. Now
Yes.
okay, I heard you. Thank you. The thing that I did not put up in here is the chat box. Mr. Little, are you
I see the chat box, yes.
okay? Good. And the chat box is empty today, folks, and that's a little disappointing. Thanks, Jakai. Okay. Now here again, it's just here. It's another illustration of what I've been talking about. If you cut off a small end of the wire, this little piece would have the same intensive property of conductivity as this entire long coil or roll of wire. So a great illustration of the amount of stuff doesn't have any bearing on the intensive property. This little piece will have the same intensive property of conductivity that this whole roll of wire will have. Okay? Any questions with that? Why do you think that is? Put it in the chat box. Why do you think that little piece of wire has the same conductivity as the roll of wire? Put a response in the chat box, please. What have we been talking about? Come on, folks. I know it's Monday morning. I know it's relatively early. Still works for the same thing. Can you explain that a little bit more, Alex? You're on the right track. Okay, Jakai, that's good. Yep, Alex, that is true. But primarily what I'm looking for here from everybody is that it's still wire. So we know that the wire can conduct electricity. So it really truly doesn't matter. Basic definition of intensive properties. It does not depend on the amount of the substance or the system. If it conducts, whether you have the small piece or the big long coil of it, it will conduct electricity. Think of color. It's still color. Doesn't matter how much color you got. It is still color. Or an odor. Those are some pretty good examples. So it is the conductivity, it is the property of the metal itself, or the color itself, or the odor itself, not the amount of the odor or the color or the length of the wire. Okay? Everybody clear? Jerry, yeah, they are the same thing. So yes, in technically, since it's the same stuff, it's going to have the same properties, no matter what the length is. Okay? All your responses are good. Very good. And I think that if you start with this list that we were talking about, the two columns that we talked about in the beginning, I think it'll even be easier to distinguish these intensive properties and why they are, even more importantly, why they are considered intensive properties. Very good, folks. All right, what I want to try to do here, this is going to be interesting. I want to show you just a short video. It's about 3.5 minutes long. Hopefully, can everybody see that?
When you study chemistry, there's a lot of things that come up when you're making measurements, and we'll refer to it being an intensive or an extensive property or variable. And what we mean by these is we really mean it's a property that changes with amount, or it's a property that's more intensive, which doesn't change with amount. And right there is really what your definitions are. Any property that you can measure that as you change the amount of substance, but that property doesn't change with the amount, is called intensive. A really great example of this is temperature. It's one of our premier intensive variables, if you will. Great example, if you had a glass of water that's 25 degrees C and you pour half the water into another glass and ask yourself, now what's the temperature? The temperature is still 25 degrees because it's an intensive property. It absolutely does not matter about the amount that you have. It's intensive. Now, let's compare that to the mass of the water. If I have a glass of water, I know its mass is, say, 500 grams, and I pour half of it out. Now the mass is not 500 grams, it's 250 grams. That's because that's an extensive variable. Extensive properties vary with the amount, and we love to quantify amounts. We quantify mass in grams, we quantify amount itself in moles of substance, we quantify length. How long is something? How tall is something? Volume's a great example of an extensive property that actually brings in length 3 times, height, depth, and width. You multiply all 3 of them, you get yourself a volume, which is very extensive. You get more amount, you get a bigger volume. An interesting thing, though, about extensive properties, if you ratio one extensive property against another extensive property, you get an intensive property. A great example of this is density. Density is mass per unit volume. The mass is extensive. The more you have, the more mass you have. Volume is extensive. The more volume you have, the more the number goes up. If you ratio them, mass divided by volume, you get density, and that's intensive. The water example I gave earlier, when I pour it, doesn't matter when I split it. The density is still approximately 1 gram per milliliter. Even in the part I poured off, it's 1 gram per milliliter. So this is an important concept you will see over and over when you're answering problems numerically in a chemistry class. Is the answer an intensive or is it an extensive property? One last thing. Extensive properties by themselves tend not to reveal much about what the substance actually is. For example, let's say I have a substance and I tell you it's 500 grams. That really tells you nothing about the substance other than the amount I have. But if I tell you I have a substance that has a density of 1 gram per milliliter, it really limits you on your choices of what that could be. And so what we tend to do in the sciences and what we do in chemistry is we list intensive properties. And if you get a good listing of them, it truly identifies that substance as being a unique version of those intensive properties. Meaning we like to characterize matter by listing intensive properties. And that's really what the importance of both of these things are, and you need to keep track of them.
Good. All right. Now, that was a little bit premature for what we're going to actually be talking about for the rest of the week here. But in any event, just wanted to give you some insight on the intensive properties and how it can actually be related to extensive properties. Now, I hope that that helped. If you have any questions, you can always, you can always go back to looking at this video. The PowerPoint has been posted up, so you will be able to watch this again. If also too you have any questions with it or have any problems in viewing the video again, just reach out and I'll be more than happy to share the link with you. Okay, so just an overview of what we've been talking about so far today. An intensive property is a property of matter that depends only on the type of matter in the sample, not on the amount. So what is it? Color, the metal, the conductivity of a metal. Okay, all the examples that we talked about before, and I'll go back up to this. The intensive properties of matter. All of these are what we are actually talking about. Okay, and we'll get into extensive tomorrow, so you'll be able to really put this whole thing together into comparison. Okay, color, temperature, solubility. What does that word mean? Put that in the chat box. What does solubility mean? We just talked about it last week. Remember
Think of sugar. I'm sorry, Mr. Paul. Think of sugar in your mouth.
Remember the term solute and solvent. Okay, and we're talking about the word solute. Okay, we know that there's a little amount and there's a big amount. We know that the big amount usually is the water. And like Mr. Little said, the solute would be the sugar. So solubility is the ability for something to actually dissolve in water. Now we only have a couple minutes left, and what I want to do here is I want to look at this. And we can put all of our answers, our responses in the chat box. How is the density of gold? How can the density now, be utilized to show an example of an intensive property? Keep it simple to start the conversation out. What have we talked about? What is the literal definition of it an intensive property? Go ahead, put it in the chat box.
Mr. Paul, if I could interject,
Sure.
density is a very scientific term. I want to put this into very unscientific terms.
Okay.
How heavy something is for its size. You go to the supermarket, you want to get a really good orange. The best way to get a juicy orange is to pick them up. If it feels heavy for its size, it's full of juice. If it feels really light, doesn't feel as heavy for its size, it's dried up. So how heavy something is. You pick up a watermelon, you're like, oh, this is heavy, it's juicy. You pick one up and it's light, it's like, oh, it's dried out. Does that make any sense, people?
Okay. I put it in there, how heavy it is for its size.
For instance, some of you guys that go to, I don't know if anyone goes to Home Depot or Lowe's, if you pick up a plastic pipe, it's pretty light for its size. Whereas if you went and you put that down, you pick up a cast iron pipe, one of those black cast iron pipes, it's really heavy for its size. It's got a higher density. That makes sense?
Same size pipe, folks. If you grab a 2-inch pipe, plastic pipe, and then you pick up a 2-inch iron pipe, same size. But like Mr. Little is saying, the density is totally, totally different. Anybody?